So here we are again, gang, and we are going to do this lab after we do this activity after we build the ramps in the phi, but I want you to see so you have an idea of what will be happening going forward. I basically have a ramp, not quite like yours, but I have a ramp set up there. I have my ball in a cup just so the ball won't roll down the ramp while I'm talking. And I have a distance on the table in front of the ramp. So that when I release the ball will roll down the ramp and across the table. We don't care today what the ball does on the ramp. We want it to go straight down the ramp. We want to be able to always start the ball in the same place. So you need to figure out with your team, are you going to always start the ball with the front of the ball at the front of the back of the line, at the front of the line, the back of the ball at the edge of your ramp? Maybe you put an X on and always set the center of the ball on the X. You want to have a way that you can repeatedly, day after day, week after week, be able to put that ball in exactly the same starting place. You want a fair amount of accuracy and precision here. What our activity today is going to be is to determine what the average velocity of the ball on the table was. So we don't care. We are only using the ramp to get the ball going. What we want to evaluate today is how fast did the ball travel across the table. You want to do that. You want to make a plan ahead of time with your group, with your team, so that you have precision, accuracy, and a fair degree of certainty, or whatever certainty your tools and your technique allow for. You can't claim more certainty than your tools and your technique allow for. So you need to really consider what that level of certainty is, because when we go forward, we are going to look back at this answer and say, how certain was this answer compared to the next answer? How precise was it? How accurate was it? You are going to want to document everything you do so that you can repeat it, even if all of you are not here again the next time we need to consider these things. So I have made available to you a group notebook with your team members in it, and you can write in that OneNote notebook, a digital notebook that you all have access to. The pages can't get lost. It will always be there. I've made a team notebook, and that team notebook, you should document your procedure, the data you collect, how much data you collect, what your result is. Did you do an average? Did you do it once, or did you do it multiple times so that you could claim more precision or evaluate your accuracy or your certainty? We want in the future to be able to look back at these results and compare these results to results you are going to get in the future. In other words, which result was more accurate? Which result was more precise? What was the level of certainty in your result? Remember that certainty is recognized by the number of significant digits you claim in your answer. And you cannot have more certainty in your answer than you have in the data that you collected. What we want to do, or what you want to do, is find a way to collect data that will allow you to determine with precision, accuracy, and whatever your technique allows for certainty, what the average velocity of the ball was when it rolled across the black top of the table. For this exercise, we don't care about the ramp. It's just getting us going. We will care about the ramp in the future. And therefore, you need to start the ball in a way that you can repeat. These are the things that last year students said they did not understand as we got further into the activity, that they would have to come back and look at those results and compare the results from the first ramp activity to the second ramp activity, to the third ramp activity, to the fourth ramp activity, and use that data and the results again in the future. You can insert a table in OneNote, you can type into OneNote, you can draw into OneNote, you can insert a photograph into OneNote. It's like having a research notebook. You want to have what you did in that OneNote notebook so that you can, and I can, go back to it. I'm going to correct your work in OneNote. You can have a different section in it, one that you do the work in and another one that's what you turn in. You can have it all in one section, but ultimately it needs to be clear to me when I read it what your procedure was so that I could repeat it if I needed to, what the data you collected was, maybe a data table. If you need to graph something, include a graph. What your results were, what the units were, what the certainty was. Those are the things I'm going to look at each time we do one of these activities. And you will get a grade on each new activity. But each time you will be asked to compare your results back to your previous results and see if they do compare, whether they should compare, whether they are comparable, whether some are more certain or less certain. If you have any questions about this, ask in class now, ask anytime along the way. What I'm not going to tell you is how to design the experiments or how to document your results. Those are things you need to work on with your team so that you have a design which is going to allow accuracy, precision, and certainty, and that you are going to have a way to represent the data and the results so that somebody observing that understands what you did and what your results were and how you came to them. Any questions, we can talk about them in class.